Okay, so we just found the derivative. The instructions had read, using the definition of the derivative, calculate the derivative. We did that. We found that if y equals 4 over 2x minus 5, then we did all that algebra, lots of algebra. We came up with y prime equals negative 8 over 2x minus 5 quantity squared. No real reason to FOIL out the denominator, just leave it like that. It's not wrong to FOIL out the denominator, but there's no reason to, so we'll just leave it like that. Now yes, there are shorter ways of doing it, and when we get to the shorter ways, you can use the shorter ways, but we aren't there yet. Then the other thing this problem said to do was to find y prime of 1. Well, that just means plug the 1 into the derivative. And so then that's negative 8 over 2 times 1 minus 5, quantity squared, which would be negative 8 over negative 3 squared for negative 8/9. And there's that value. Then if this, that would then be the slope at 1. If this represented some sort of position function, that could be the velocity at time 1. And yes, velocities can be negative. A negative velocity just means whatever's moving is moving in a negative direction. In kind of a two-dimensional world, a negative direction is down or left. But velocity can be negative. And there's the first problem. So on to the next problem. Just using the definition of the derivative, calculate the derivative. So f prime of x is going to be the limit as h goes to 0 of f of x plus h minus f of x all over h. And we just start working that out again. And so that's going to be the limit as h goes to 0 of 2 times the quantity x plus h plus 3 minus, or then the square root of the quantity 2 times the quantity x plus h plus 3 minus the square root of 2x plus 3 all over h. That's your f of x plus h. That's your f of x. One of the most common problems is right here, not remembering what f of x plus h means. That all that means is to take your formula for f and replace the x with x plus h. That's all we've done. And then for the f of x, that just means the formula itself. And now we're going to start working this out. So that's going to be the limit as h goes to 0 of the square root of 2x plus 2h plus 3 minus the square root of 2x plus 3 all over h. And as we've done for so many common limits with radicals, square roots rationalize. And again, I won't write it down, but if we substituted h equals 0, we would get a limit of the form 0 over 0, which is indeterminate, which means we have to do something else. The something else with radicals or with square roots was to rationalize. So we have the limit as h goes to 0 and the square root of 2x plus 2h plus 3 minus the square root of the quantity 2x plus 3 over h. In this case, we're rationalizing the numerator by multiplying by the conjugate of the numerator, and multiplying numerator and denominator by the conjugate. In the numerator, multiplying conjugates, you always get first term squared minus second term squared. And yeah, I am showing every single step. Now, if you forgot that a plus b, a minus b always multiplied to a squared minus b squared, you could FOIL out the numerator and you would come up with the correct answer. It's just going to take you longer. And in the denominator, I'm not going to do anything except write those guys side by side. Because again, my ultimate goal is to cancel that h. And if I distribute that h through, it won't be as easy to cancel. Keep doing the algebra. So that's going to be 2x plus 2h plus 3 minus the quantity, 2x plus 3, all over that denominator. Notice the parentheses. Parentheses, required. One of the most common mistakes is people do not use their parentheses appropriately, and then things just don't work. But because I have those parentheses, I can distribute that minus sign. And once I distribute that minus sign, good stuff happens. This is supposed to be plus here. Lots of stuff cancels. And that's why the parentheses were so important, that allowed all the things without an h to cancel. If you get to the point, you get here, and there's still stuff running around that doesn't have an h in it, you probably have missed some parentheses somewhere. And so we get the limit as h goes to 0 of 2h over h times all that stuff in the denominator. And there is my goal. I can cancel the h's. That is always your goal. And so I've got the limit as h goes to 0 of 2 over the square root of 2x, square root of the quantity, 2x plus 2h plus 3, plus the square root of 2x plus 3, substitute h equals 0. Once I get to my substitution stage, I can drop my limit symbol. I should keep my limit symbol every single step until I get down to substitution, then drop it. If you drop it too soon, I will not take off for it, although it's technically wrong. I won't take off for it. But like I said before, students that drop it too soon have a tendency to stop right there because they don't have that limit symbol anymore. And so once they do the algebra, there's nothing telling them to substitute h equals 0. So be sure you remember that, next to the last step of substituting h equals 0, or maybe not next to the last step, but almost the last step. Which gives me 2 over the square root of 2x plus 3 plus the square root of 2x plus 3, which is 2 over the 2 times the square root of 2x plus 3, which is 1 over the square root of 2x plus 3. So what we just said is this. So, for f of x equals the square root of 2x plus 3, the derivative f prime of x is 1 over the square root of 2x plus 3. And then like I said before, if you happen to know the shortcuts or the basic rules for differentiation, you can certainly check that by looking at those basic rules. Okay, we'll end this video with this problem.